All right, let's go ahead and get started. Can everybody hear me? Okay. So I just have a couple things to mention, and then I'm actually going to break you up into your groups for a bit, and then we'll come back together. So I just wanted to make a couple kind of announcements and so forth. I uploaded the some portions of lab reports from the last, I believe, 4 years. So I put the procedure section and I put some figures to give you an idea of the experiment that they chose to do, and some very basic kind of results from that. So those are up in the share drive in the folder that's basically Lab 1 ion exchange. So that one. There's also a share doc that David made for us in the same location. So the idea with that is that normally we might have a whiteboard and kind of jot down our plan of action and our brainstorming kind of session to see what different kind of ideas we want to look at. So basically, when you're talking with your groups, you can go ahead and kind of make a subsection about, group 1, group 2, etc., and kind of put down your thoughts, what you guys are thinking about, any questions you might have, and I can also pop between different groups and answer questions if you have them. So basically, that's what I want us to do for this first session, is to basically I'll break you out into your groups as you've kind of made them. And then I want you guys to discuss, maybe for like 10 to 15 minutes. And then we'll come back together, and the rest of it will just kind of be us chatting as a group and see if we can get to kind of one consistent idea and all of that. But before we do that, I do want to leave it open to questions in case you've kind of looked through things and you have some additional questions for me. So if anybody does have any, let me know before I break you out to groups. Everything good? Okay. So I'll go ahead and start doing the breakout rooms. So if you want to go ahead and take a look at the document and the old lab reports while I do that, and make sure you know where to find them. And then if you don't, let me know. I will assist you with that. Okay, I'm gonna go ahead and open them all up. So if you guys want to chat as a group for about 10, 15, and I'll get you back together. All right, so it looks like everybody is back. So why don't we go ahead and does anybody have any questions that they kind of came up with during the group talks?
Just to sort of verify, we're looking to have around a dozen different sets, a dozen or less different sets of tubes for testing, right?
Do you mean condition, like different conditions that you can do, or are you talking about something else?
different conditions. So for
Okay.
example, a control would be 30 tubes without any treatment at all.
Mhm.
And we want to have a dozen or less of those. Keep
Yeah.
workload reasonable.
So I went back to look in the old lab reports and what I remember, just to make sure I had a rough estimate. And I'm pretty sure that kind of my advice to the groups was 2 per group. So that's obviously a little weirder this semester since the groups themselves aren't running it specifically. But I think that would be a good estimate, is about 2 per group, and then you can kind of add on a control or 2, because usually the controls we just have to make sure we have glass samples for. So I'm open to altering that a little bit if there's, if we get to the point where we're just like trying to cut something, I'm open to expanding that a bit, but that's a good starting point. Is basically 8 plus any controls you have. And we'll see if that works, and if not, I'm opening to move it up a little bit. But yeah, I think probably past 12 and it would get kind of unwieldy for us to do. So I think that's a good starting point. And yeah, it does have to be about 30 of the glass rods per set. Usually it holds a little bit more, so usually we'll put like 32 or whatever is can be held in these holders that we have, and you'll see these in the videos. I'll make sure I show you what they look like. But yeah, that ends up being a lot of glass. So any other questions that you guys came across while you're kind of looking through the old results, or talking amongst yourselves? All right, so then let's go ahead and just kind of go through some of the ideas that you guys have, and see, a lot of them might be kind of similar, so we can kind of maybe merge that. I just got a question in the chat. Yeah, so the when we get the glass samples, I don't know what's been done to them. I can't even get, honestly, I can't even get the exact composition for you. The most I can kind of tell you is that it's soda lime or flint glass. This glass is kind of supplied to us through kind of educational stores, because it's meant to be kind of for science demos and stuff. So it's not really like high precision stuff that you might buy for research if you're working in a research group. So we can't even really, we've tried over the years to try to get the composition, like a detailed like sheet of that, and we can't find it. So we don't necessarily know how it's been treated. If you do look at some of the past results, sometimes when we do a pre-treat, like a preheat or something like that, and we try to run the testing on that to see if that has any effect, it does seem to have a little effect on the bin testing. So there could be a little stress from kind of processing. It's not super noticeable, but there does seem to be a slight bit of something that's happened to the glass rods during processing. So typically a preheat does kind of will expose that a little bit. So but yeah, we are able to do any most kind of pre-treatments or preheats that you want to do. And that's one of the things I was going to ask about, is that's not necessarily something that you guys think about until you actually run it. But these salts that we're treating, the idea is that they're going to be molten. And so when you look at sodium or potassium or silver, you look at the melting points, and they are in that 300 range. And if we are operating the furnace really close to the melting point, if we put cold glass in them, they will tend to solidify. And so often we have some type of preheat that we put the glasses in. So basically we would put the glass rods in the furnace, just in air for a set number of time to get them up to temperature so they don't solidify the nitrates. So some type of preheat is typically necessary for this. So that's something you want to think about. And then, yeah, there is a slight effect that has, and so we're up for examining that as well. Okay, so let's kind of go over the various groups. So you all have access to this this document, but maybe just for kind of clarity, if somebody from each group kind of wants to go through and kind of just tell us briefly what your thoughts are and so forth. So we can just start with 1 and go to 2, 3, 4. So anybody from 1 want to kind of share with us briefly what they were thinking for conditions?
So for group 1, the main interest was in changing up some of the composition as sort of the primary variable. So treating with all the available solutions and then doing an ion exchange pre-treatment where it was soaked in a sodium bath and then treated again with silver, and taking a closer look in the SEM to see how far that sort of penetration either increased or decreased if we pre-treated it with the sodium.
Okay, so basically, like basically having 2 treatments. The first with potassium, sodium. I will mention that the other 2 we typically can't get the high concentrations on those. I think 5% is the highest we've ever gone on silver, just because of kind of how much we're able to purchase. And then a second treatment with the silver is kind of what you're thinking on that, and trying to see how far that gets. So the main, I guess, focus of that experiment would be looking at composition and seeing how far that goes. So I think that's doable. You would have to kind of think about the initial treatments because of the the silver and the lithium having to be less than 100%. So that would be one thing that you'd want to think about. And then if we did do this, you'd want to kind of think through your hypothesis for what that would do to the strength, and what the strength would look like for that. So that was your guys' main idea for that. What about group 2?
Our main idea, we were gonna vary the time that we were treating them, and then we were gonna do 1 sample with sanded and then a control group that wasn't sanded.
So so all of them at the various times would get unsanded versus sanded?
I think so.
I was just trying to kind of see that. So what was the kind of, I mean, I like it because a lot of times we end up doing kind of similar experiments where it's like we'll pick a temperature and then kind of do different times, or and there's a lot to that as well, but this is definitely something that we haven't seen before. So what was the group's kind of thought for why or what they think will happen to sanded versus unsanded?
I'm not really sure what it's gonna do. I think Jacob came up with it's just something different that
Okay.
we're seeing, but Jacob might have something to say. I don't know.
Well, I thought we were discussing how like maybe changing up the surface area would have the glass interact differently with the solution, and just like having like a different texture of the glass and stuff like that would maybe cause it to react differently.
Okay, yeah, I mean, I'm inclined to think that it would have a noticeable effect on things. Yeah, so it does kind of bring up a surface area point of view. Excuse me. It does bring up a surface area point of view. The other thing that may have been unintentional or intentional, I'm not sure on the group's part, but if you're familiar with brittle materials such as glasses, the surface impurities, or sorry, surface imperfections, this is something that we're gonna get to a lot in 403, have a really drastic effect on strength and when something fractures. So typically surface flaws are really bad. So the idea of sanding it, again, the idea of this isn't to get like the strongest possible glass. It's to study the effect of something. So I think that would be that could be an interesting thing, and maybe not it might not, you might get the results you're thinking about, but you might have some unintended consequences if the glass breaks really quickly. But no, I think that's I'm not saying that's bad or good. I just think that's an interesting one. Definitely different than what we typically see. So let's yeah. So I think let's kind of go on to 3 and see what else the other groups have.
For our group, we wanted to do maybe like the variance in size. We kind of talked about that briefly yesterday. And so do the potassium on the larger side of things, and then do the lithium on the smaller side of things to see if like the potassium would maybe create more tension compression because it's a bigger ion. And then also, like we also talked about yesterday, just run different tests on it to see like if we can find any other kind of material property besides just like when it's going to fracture, if it's under like tension and compression and that kind of stuff. So
we definitely talked about hardness on Monday, I think.
Yes.
Yeah, that's something that we could investigate. But yeah, we're a little limited just because we're not a glass lab or anything like that, but a glass exclusive lab. But yeah, we can definitely try some different things and see if that works. The only thing I'd kind of mention here is I can't remember what year, but I know we've run something similar, I should say, in terms of like looking at lithium and comparing it to a larger ion. And just, in general, potassium, lithium is going to be very difficult to actually see with EDS or XPS. It's one of those nearly invisible elements to most things. I will say with the lithium, there's other ways. You'll notice it right after you do the treatment. You'll notice its effect. But potassium as well is really hard to see with EDS. That's why we're kind of giving the XPS a shot. So I'm hoping in the next week to be able to tell you whether we can run XPS or not, as kind of a more a better way of looking at something like potassium. So I'll have to get back to you on that.
We also noticed after looking through a couple of the reports, some people, like some years, they were like, there's no mention of cleaning the rods after treatment. And then there were some like that were cleaning them. So we talked about like, yes, we should clean the rods to get all that excess salt off of there, because you're going to be able to see that result better.
So I did kind of pick and choose lab reports, I'll say. So that was just like the procedure section. I believe everything would have been cleaned other than maybe controls. I don't know if people thought to clean the controls with nothing on them. But yeah, so definitely that's something that we want to consider is clean them after, but we can also talk about cleaning them first if that's if you think that's an issue as well. So yeah, so let's go on to group 4. What do you have for us?
So what we wanted to vary was the salt used in the ion exchange, and how we wanted to do it was have 4 different samples, one with a control, maybe no salt, not 100% sure there, and then 2 different salts, so maybe the silver nitrate, potassium nitrate, and then 1 bath with both in the same to see what that would do to the rod.
Okay, so so kind of like so I see on yours it's like sodium and lithium. So the idea would be you'd have a control, then you'd have one go into pure sodium, one go into pure lithium, and then like a mixture of the two.
Right.
Okay, yeah, that could be that could definitely work. Again, the lithium, I don't know if we'll be able to get enough for like a 100% lithium, but we could do potassium and sodium are really the ones that we are kind of our base salts, we kind of call them, because we have big buckets of them. So we can definitely do 100% of those, and then the other ones we tend to have to put some percentage to. So that's something to kind of consider with this. But yeah, so I mean, so basically you're kind of thinking of concentration, right? Because in essence, you're 100% of the other, and then a mixture is kind of looking at that. So I think that could be useful for looking at kind of the effect of pure versus some concentration of that. And so then everything else would be kind of constant for that, right? So like the time and the temperature, or what are you thinking else with that?
As of right now, we're planning to keep everything else constant.
Okay.
We're going to look at a few of the other lab reports before we make a final decision on that. But I think, what were the 2 salts you said were the most common?
The ones we have like buckets of are potassium and sodium. So we can do, because essentially what we have to do is we have these, if you've ever seen like food service, they have like the little stainless steel cups that you put like forks and stuff in. Basically, we have to fill one of those with the nitrate so that we have enough volume to cover the glass rods. And so silver nitrate is a little bit expensive to, fill with a kilogram of salt. So we tend to have to, look at using tens of milligrams or hundreds of milligrams of something like silver. And we have lithium. We have a little bit more, but probably not a kilogram worth. So the sodium and potassium are the 2 that we have the most of.
That makes sense.
All right. So so we've kind of got a kind of a view of what each of the groups were thinking as they talked amongst themselves. So what I want to do now is basically leave it open, basically, the whole class like it is now, and see if you guys can kind of, talk about your various ideas, see which ones you like now that you're kind of talking together, because we will want to kind of get to one plan for the entire class. So there might be elements that we can incorporate from various groups and so forth. So, I want to have, because of the number of samples that we have to run, we kind of need one plan that has, the roughly 8 or so conditions to test. So I'm going to kind of, mute myself here in a second so that you guys can kind of talk as a class and talk about the aspects you like, the aspects you don't like, maybe how you can kind of merge different ideas together. But I also want you to think about, as we kind of go through this, not necessarily like, this sounds cool, I want to do this, but also kind of start to form like your hypotheses for what you'd want to do with the experiment, because then we can kind of match, well, this is my hypothesis. Does it really match with, what my experiment actually is? And maybe we have to add a control or vary something slightly so that we can do it. And so see if we can kind of merge ideas. And then once we have that, I would definitely like to start to iron out some of the details, like what temperature what times, concentrations, all those kind of things that we need to do. So let me just real quick give you kind of a list of things to think about for the ion exchange treatment. So if you're going to do any sort of pre-treatment, I know at least one group talked about that. I mentioned the preheat thing, which I think can be is pretty useful or necessary in a lot of cases. So you might think about how to preheat the glass. You want to think about, if you're varying temperature, obviously think about what temperatures. If you're keeping it constant, make sure you kind of look at which temperature you want to investigate. Same thing with time and concentration. So all of those things, if you're not varying it, kind of pick one, and you can kind of go back into those old lab reports if you need an idea, or if you want to ask me as well. And then also think about the removal too, the last part. So how you want to get it from the concentration and the temperature that you have to cool it down to room temperature. So you might think about how you want to do that as well. So those are all kind of things to think about as the group. So I'll go ahead and mute myself. And so, feel free to talk. Obviously, everybody talking at once isn't going to work. So, try to be courteous, but I would like kind of a discussion amongst the various groups. So I'll mute myself. If you have questions, feel free to ask me and I'll come back. I'll be watching. So, all right, I'll let you guys at it for a few minutes.
I think the sanding idea is very interesting, and we should definitely do that.
So what would we do along with sanding, you think, then? Because I think sanding can only get us so far. We still have to vary something else.
I think that whatever we choose to do, we do like the sanding on like in addition to that. I don't know if it's something that can stand on its own.
I agree.
I think David's typing in this document, but we can just go down the line and see. So for the baseline treatment, do we want to do a pre-treatment, like heat it up beforehand so that the salt doesn't solidify?
I definitely think that could be useful. I think that a pre-treatment, like a pre-heat, would be a good idea. Like Sydney said, like so it doesn't like solidify on contact with the like cold glass rods.
Any ideas for temperature or time on that, just based on some of those other reports we read? I think I saw 350 for half an hour on a couple of them. Any objections to that?
I think that would work.
Okay. And then for the control group, do we just want to have some glass rods that are not pre-treated at all, and then some that are, just to kind of see that difference, and then we can go from there as well? Or do we want to heat up all of our glass rods?
Yeah, I feel like doing like a little like both of them would show kind of like how they differ.
Yeah, I agree. I think that we definitely could do like some preheated and some not.
I know our group is like really leaning towards just testing like the different composition of of like nitrates. So I don't know what everyone else is leaning towards, whether they want to like test the temperature, but composition was one that we were really interested in.
It seemed like the time of how long we put it in the furnace affects how deep the salt actually penetrates.
Yeah, I think we should definitely do some like variance of time in the solution in the furnace, whatever. Because yeah, we did talk about that in our group as well. I didn't even mention that, but I think that will definitely affect like depth.
I'm not really sure if we like how many things we can vary, but like we should probably decide between like either doing like just like varying the salts or varying like the temperature, because if we do like if we vary too much, then we won't really know like how it's affecting it. I don't know, like maybe they're just like two different things that we won't be able to like do all of it. I'm not sure.
No, I kind of agree. Like, I feel like we need to choose one major thing to vary so we don't have so many differing variables and we don't know what's going on.
I was kind of thinking that maybe the temperature would be like the easiest thing to vary because of like the limitations on like the concentrations of the different materials we could put in. But the the different salts would maybe like have a more interesting thing to look at. I'm not really sure what everyone else wants.
I think looking at the time would be really interesting, and probably holding the temperature constant, but that's just me.
I think varying the temperature, I feel like we won't find like a huge difference in that. Like it's possible, but I feel like you're going to see more of a variance with different types of salt and different like time periods in the furnace.
Yeah, I agree with Sydney. I think either the time or the concentration, that's like pretty much what I'm voting for.
I guess I would also vote for the concentration. It would give us like more stuff to look at.
I'm gonna have to say the same. I think I agree. Concentration would probably be the easiest, but also most like visible change between the rods.
We could do sort of like a variance in concentration and then a variance of exposure to that concentration.
Yeah, if we were gonna do like different times, we could like pick like maybe like 4 or 5 different combinations of salts and then do one for like short and one for long. So there's just like 2 for each, so there isn't like too many samples, but then there's like one that's in there for like a really long time just to see what would happen with it.
I definitely agree. I think that if we did time and composition, we would find different, like, I feel like that would be not too many, like, big things that would be varying, but we would find a lot of different results, I think, throughout just doing those 2, like, big variables. Like, so like Sarah said, like, pick a few compositions and then do, like, 2 different time periods for that. And I also think that those are going to be easy things to write, like, hypotheses off of. So, like, if it's in there longer, we think it will, like, penetrate the glass rods more. If it's like a different composition, it'll be less or more compression, like things like that.
I agree. I think having the 2 like standard time periods would definitely make things more simple and easier to detect.
So in the in the chat, David put like 350C to 450C. Would that be like our low temperature and then high temperature? Is that something we could do, I guess?
Yeah, I think that's what maybe the past reports used for their temperatures and times when they were testing.
What do we want to use for a control? Short time or a long time?
We could also just do both of the times on the control, I guess. Oh, wait, if that's like the amount of time that it soaks in the solution, then wouldn't the control like not be soaked in the solution?
Or we could have the control in the short time period and compare like if the longer time period did better or had more effect on the salt on the glass rod.
I also like what Sydney said earlier about like cleaning all of the glass rods. Like I feel like that would be a good thing to do for all of our samples.
Was that cleaning before or after the treatment?
We were talking about after to make sure like all excess, but I think that doing it before would actually probably be a good idea as well. Just to make sure that there's no like dirt on, I don't know, like whatever, when they're getting stored. I don't know. I'm assuming they're not getting stored in dirt, but you know, just like so they're clean before and after, just so we can get the most accurate reading of like what's actually happening chemically without like interactions from around.
All right, I just wanted to jump back here for a second to kind of see things seem to definitely be progressing. So yeah, so cleaning, things like that might hold off on. We can do those. I don't think there'll be much argument for that. I want to make sure it's not getting kind of I guess so the initial like kind of sanding idea, I don't know if we went away from that, but I would say if that's still on the table with the other kind of two variables, that's going to be a lot to try to tackle in one experiment. So if that's still on the table, you probably want to limit it to probably one, I would say, variable. Whereas if you're thinking about looking at something else, then two is probably the most that you can kind of vary with the numbers that we have, I would say. So that's just something I wanted to make sure you guys were thinking about, because there's a lot of ideas, and I know bringing a lot of people together can be challenging. So but just think about that. I hadn't heard about the sanding thing for a while, so I just wanted to see that. But yeah, I would probably try to stick to two types of variables and go from there. If we're kind of at an impasse or something, we can also kind of just poll everybody or use the chat and kind of just see if people have like agree with an idea or not. So if you want to do it that way, if you think that there's just kind of too many ideas, you can start using the chat, or I can set up a little short poll for everybody just to see what the consensus is amongst everybody. So I'll go back on mute, but if you have any questions, let me know.
I think Jacob was saying that the sanding would only be like one trial, like it would be kind of like the control, but like a separate thing. Like we would just do like one of them and just use it like outside of, like we wouldn't do like one for each of the salts or anything like that. And like if that's too much, we can always just like ditch it, because it kind of sounds like all the other stuff would be like more of a complete experiment.
No, I mean, as a kind of a standalone thing, I think that's doable. I guess when I heard it, I was thinking that you were going to have basically, for example, different times, like 1 hour, 2 hour, 3 hour, 4 hour, whatever. And then you're going to have a set that was unsanded and a set that was sanded. So like all of the treatments, would have both. And so, that obviously kind of doubles the conditions. But if you do just want to kind of do it as a standalone, that's just one set. So, that's doable. So it would just be, no treatment on it at all, just kind of sanded and see what that looks like. Is that the idea?
Yeah, so like I think what the plan was so far is to have like maybe like 4 or 5 different like solutions and like have 2 different times for each of those. So maybe like 8 or so samples, and we'd also have the control and then like just one for the sanding.
I kind of like the idea of sanding and then doing treatments, because then nobody else has really done that in previous reports. I think that would be something at least new. If it works, it works. If it doesn't, it doesn't. But it's at least new. I think composition would probably go best with that. Just change composition, have 3 or 4 different compositions, probably not use the silver and the lithium just because the concentrations would be so low, but just stick to different mixtures of sodium, potassium. And then that also depends on if we can pick up potassium in the XPS.
I guess there is the possibility that we could do in like instead of the time that we do the sanded versus unsanded in all the different salts, but then we would not get to see what the time does.
Yeah, I was gonna say like pretty much what Alex was saying. If we do like all of the different compositions that we want unsanded, and then all of the compositions that we want sanded, and then that could be like our whole procedure. But then that, yeah, what Sarah said, like that'd be excluding varying the time. And I don't know how strongly everyone was leaning towards testing the duration.
I feel like duration has been done before, but sanding hasn't. So like, I don't know. Do we want to like poll in the chat? Just like everybody say if you'd rather do sanding or if you'd rather do like time duration, and then we can just take off of that.
Yeah, so I guess if no one saw it, Jacob was saying that the sanding he didn't think would have as much effect as the time. So by trying something new, he would be taking the risk that it just like wouldn't really do very much. But we could just take a risk, I guess.
I like David's idea, standing on one composition only, duration otherwise. So if we do like, kind of like he's written down in the document. So if we do a control, you know, we have 100% sodium nitrate that's sanded, one that's like not, and then do duration for the rest of the things, then we would have like a little sample of that. Or would that be the like too many variables that we were like, or would that, anybody know?
Yeah, maybe if we just do it on like a really simple composition that we choose, that would be easy. Or if like we even like waited and saw the testing results on all the salts, and if there was one that was like kind of being weird, we could see it, we could try it on that one.
I would say if you want to kind of sketch out, and I think you're doing that right now, but you know, if you have, you know, it sounds like sanding is pretty popular, but there's still kind of some ideas for time and composition. So if you want to, you know, just kind of, even if it's, you know, one person just put a proposed kind of, these would be the various conditions, and we see what number we get to, because, you know, if there's still kind of a holdout that is interested in something like time, I think that time effect is, you're mostly kind of interested in the surface composition. So what I would add to that is keep in mind that, you know, the most significant results we've had with composition, being able to detect it, have been with silver. So if you run something like sodium or potassium or lithium, we might not be able to see that in EDS. And so you kind of have to keep that in mind as far as results. So you might be able to do something where if you want to look at time, you just look at, you know, the silver stuff, you know, you do it with that. So there might be a way of concentrating on one thing. So if you want to kind of just, if you have an idea, maybe just kind of put in a little box or something with what samples you think you need, and we kind of see where we get with that. But I think we're kind of slowly converging to one idea.
So if the potassium won't show up, would we rather trade out everything that we've got listed for potassium for silver? So because they're both going to be larger ions, the potassium and the silver ions are both larger than the sodium ion. So where we have, you know, potassium nitrate, 100% potassium nitrate, 50% sodium nitrate, 50%, would we want to do that as silver? Or would we rather, like it's being typed into the document, do silver replacing the sodium?
If we did everything with silver, what's the maximum concentration of silver we could have?
I think you said like 5%.
5%?
Yeah, if you look back in I looked yesterday and we used 5. I think one year we did like 0, 1, 2, 5, I believe were our kind of, that was the variables, was composition. Yeah, just, you know, as you can imagine, silver nitrate's a lot more expensive than sodium and potassium. So that's probably 5 is probably the absolute max we could do on a concentration.
Even if we did it for 10 different trials each, because they only had it for I think 2 of their trials or 3, the 5%.
I think they used those multiple times actually. So they had a 0125 if I remember, and then they used it for multiple times or temperatures. I can't remember, but they actually used them multiple times. So I don't know if we had 1 or 2. I would say in terms of don't get too caught up on the numbers, I guess, like the general. We can kind of pencil something in, and I can see what we have, and I'll definitely try to maximize how much we can use. So yeah, so we won't be able to get to 50, but you could definitely, if you're interested, we could pencil something in like 5, and I'll let you know the real numbers when we do it and get back to you on that. But I wouldn't get too caught up on the specifics. Just have like a general idea that 5 is probably the most we can do. All right, since it seems like we're, excuse me, at a bit of a lull here, can kind of somebody update me on what the, right now, maybe what the consensus is, or what we're kind of typing in here, just to kind of make sure I'm on the same page, and I can kind of steer you towards anything or away from things.
I guess it just looks like we're playing around with compositions, sort of ignoring any change in temperature, and maybe doing a little bit of duration.
Okay, so I'll just put right now, pre-treatment's the same, or preheat's the same. The cooling's the same. It looks like that's those are all kind of constants in this. Temperature, it looks like you're just kind of gonna pick one temperature and go with that. And then composition seems to be the big thing right now. So what are we thinking composition wise, since that seems to be one of the big variables that you're adjusting right now?
Seems like mostly sodium and silver and different variations with that. Maybe potassium. When will you know if we can pick it up on the XPS? You said sometime next week.
Yeah, I have. I've been trying to. I've been talking with Nico, who kind of runs the EM Center and does a lot with for us for the SEM. He's done that in the past, and he's also done some of the XPS. So I hopefully should know if he can run those. Hopefully this week. I'll get back to you on that. But silver is definitely the safest thing that we've found, because we can use EDS and we can pick it up for sure. So if you're if kind of knowing the composition on the surface is useful, I think definitely silver would be a safe bet for that. And so it looks like you've got sodium with different amounts of, or with silver nitrate in it, it seems to be maybe one of the thoughts. And so can somebody refresh me on the sanding? So this, it looks like we're I see the sanding on one of them. Is that still the case? Doing kind of a sand versus unsand on one of the compositions?
Yeah, it looks like we're just using the one composition, and we're just testing that one with sanded and then with the time, and then all the rest of them with the time as well.
Oh, okay. So basically composition and time, and then kind of throwing in one that's sanded.
Yeah.
Okay. Okay. So let's kind of because I just want to make sure it's a little fleshed out, because I want to make sure that, you know, the experiment that you've kind of got laid out, that you're going to have enough samples to kind of do what you want to accomplish, and that, you know, obviously it's not going to be, you know, 50 conditions that we have to test. So it seems like sodium and silver as the concentration, as the two salts for the concentration, one sanded, and then for the different compositions, well, it looks like 2 different times on those. Is that correct?
I believe it's 3 because we also have a set standard 4 hours for everything else.
Oh, okay. I was sorry. It's
No, it's fine. Yeah.
It's getting a little hard to read, so I just want to make sure.
Place.
Okay, so three times. So what's the idea with concentration? Are we trying to do like 2 concentrations, or what's the idea there? Because I'm still a little fuzzy on that detail.
I don't know if anybody else saw that in the chat, but Jacob said, I think we should only vary which salt, not concentration of the salt too, which I feel like would probably be smart, because if we're doing a bunch of variances in composition and salt and time and sanding, then we're going to start throwing too many things into the mix.
Yeah,
So
I think that's definitely too much.
Yeah, I like kind of just saw that there's like the 4-hour baseline, which would make it definitely a lot more confusing if we did some of them at 4 hours and then like a separate one for the 2 and 8 hours. Like I feel like we should just do like different salts and then do each of them for 2 and 8 hours. So we just kind of like drop the 4-hour thing.
So what I see now is 2 times, and then looking at 3 different compositions. And so right now you've got the sodium, potassium, and then a mixture of the 2. Do I have that right? I don't want to make sure I'm not like misinterpreting what you guys are putting out there.
Yeah, I yeah, Jacob said that's 8 testing 3 different composition two times and sanding. I feel like that way we could leave the sanding in there and it would not get like too confusing. So we would have like around 8 different samples we'd be doing.
Okay. Okay, so let's go with this for a second, just because you know, I don't want us to go kind of down too many rabbit holes for a second. So let's say let's go with this, and I just want to kind of pose something to you guys because I see the 3 compositions. So what do you think is going to happen with, if you just consider potassium, like 100% potassium? What do you think is going to happen?
It's going to be stronger, is what I think.
Right. So that's kind of the standard standard treatment, right? So you've got sodium in the glass, exchange that for potassium. We know potassium's larger. We talked about that last time. And so then the idea would be, well, we're going to test it for 2 hours and 8 hours and see, well, I think the 8 hours is going to be stronger, you know, whatever. So I think that's sound. I guess my question is, what are you guys thinking is going to happen with the sodium?
An effect of the surface.
Sorry, Zach, we're having trouble hearing you there. So you're saying it'll dilute the potassium? So yeah, so I mean, I think in that regard, I get the mixture of, you know, doing the 50-50, but I guess my question is the purpose of the 100% sodium. I just want to make sure that I'm clear with your guys' intent for that.
I feel like maybe on that one that's like 50% sodium, 50% potassium, that we could use silver for that instead. So that way we could test like silver and the potassium.
Would you still want to have the sodium by itself and the potassium by itself? I guess I'm just I just kind of, you know, I'm trying to kind of flesh out what your idea is, because you know, I've seen this experiment, you know, I've seen the ion exchange experiment, so I kind of want to, you know, steer you towards things if your goal is one thing, right? So that's, I'm just trying to, you know, make sure that you're kind of getting a little bit out of it of what you want to do. Excuse me.
Yeah, I think Jacob said that the goal would be to test the size of the ion and seeing the strength of the glass in the compression on that compared to the potassium being a different size. So I guess that like it would just be like increasing the amount of sodium, but I'm not really sure if that would have any effect.
So one thing I'll mention here with that, because, you know, I didn't give you, you know, a complete, you know, 3-week lecture on the different compositions and stuff like that. So in our soda lime glass, the soda part of that means sodium, and there is small amounts of potassium in the glass, but it's a pretty small amount. It's basically negligible. However, the main ion of kind of interest in the glass itself is sodium. So if you're trying to exchange that, there's a potential that you could potentially get more sodium in the glass, because there are some papers out there that talk about a kind of a pre-treatment, trying to maximize the amount of sodium. But I just want to make sure that you're aware that that's what's in the glass. So the majority of what's going to happen there is like a sodium for sodium exchange if anything happens. So typically, and I hope I gave you a paper from one of the previous years, but typically when they do sodium, not much happens to the overall glass strength or composition. So just wanted to make sure that that's clear, because if the purpose is to have kind of almost like a control, that I think that's beneficial. If you do want to see if there's some type of, like, they call it packing effect, that's going to be useful. But overall, since sodium is in the glass and you would be exchanging sodium, the kind of size effect there is basically void, because they're the same size. So I just want to make sure the intent of what your experiment is.
So I believe what you're saying is that like the 100% sodium would just kind of be the same as the control.
Yeah, I mean, I hope I didn't put every single year that we've done this experiment up, but I put 4 or 5 of them, and I know we've done some variations with just sodium, and they do show maybe a minor influence, but also the heat does that as well. So from what I can recall, there wasn't a big effect with that, and definitely I don't think you'd be able to tell anything on composition. So if we look at it with EDS or XPS, I don't think we'd be able to see any difference there.
Yeah, I like what you've been saying about like the silver being able to show up like a lot better. Like I think we should definitely use that instead. And like it sounds like that's where you're trying to steer us, is to use silver. So we could definitely include that.
Well, I mean, you can. So the so sodium just kind of tends to be a blank slate, honestly. So that can be important if you need some controls, or if you want to look at it, that can be useful. But yeah, we know silver. We've seen that if you kind of go back to the old reports, you'll see that silver strengthens, and you can see it. And then potassium, you can see that potassium strengthens, but we've had difficulty, or basically haven't been able to see it with EDS. So I just want to make sure that you're kind of know what we have. You're going to have a different experiment to some extent, but I want to make sure that you've gotten some of the past results of what we've seen.
Yeah, so I think we left the 50-50 sodium, or I mean like potassium and silver for the 2 hours and the 8 hours, just like to see like if like a mixture of the two does anything. But then like, yeah, we did change the sodium to be silver, and then we have potassium, and it looks like we're also doing the potassium is going to be the one that we sand as well.
Okay. So yeah, so I think that will that will work. Obviously, like I mentioned earlier, the numbers, we won't be able to use the pure silver, or even the 50%. So on those cases, for example, for the mix one that you have, which is potassium and silver, would you prefer that we do, for example, like a 5% silver and then the rest potassium, or do you want to fill it in with sodium and make it like a triple salt?
I think that just mixing the two of them would probably be our best bet. So 5% sodium, 5% silver, 95% potassium.
Okay. I just, I want to make sure that I'm not misinterpreting, because in the next week we will have to run this for you. So I want to make sure I've got everything. And then okay, so we can definitely do that. And then for the sodium by itself, or sorry, for the silver by itself, then would you want to do a 5% silver, rest of it sodium?
Yeah, like instead of doing like all of them potassium and just adding a little bit of silver to some of them, we could do like just like, since sodium is sort of like the baseline, we could add silver to that and have that be like instead of 50%.
Because that first one up here that if I highlight, I don't know if you can see that, but the silver 100%, obviously, you know, we that would cost $1,000 or so, so maybe more. So yeah, so if that I think, because that at least would give you a, you know, you would have a silver with the rest sodium, you'd have a silver with the rest potassium, and then you would have 100% potassium. I think that's if that's agreeable with what you're going after, we can definitely do those numbers. And then leave one for sanding, potassium. So you'd have, so basically for the potassium on its own, you would have treatments of the regular glass for 2 hours and 8 hours, and then you'd also have a sanded 2 hours and 8 hours in the same concentration. Okay. Yeah, I think that will that would kind of allow us to look at a number of things. With the way that it's written out right now, with these, and then also with the controls. So if we're going to kind of take this as the baseline, the group experiment right now, does anybody kind of want to just any thoughts on this? Because we still got a few minutes, but I want to make sure that everybody's kind of heard out, or if there's any issues that you kind of foresee with this, that we kind of bring them up now before the experiment.
I'm a little bit curious with the potassium silver combination. Would they block each other from diffusing further into it? Because they're such large ions, like once they get in there, could they impede the path of each other?
So this is one that I will have to admit that I don't know if we have as much data on. I want to say that we've done this at least once, but I'm not positive. I would have to actually go back myself. But I think, so I think having the quote unquote silver by itself with just sodium, and silver with potassium, and then potassium on its own, maybe that will allow you to make some conclusions about that. And so that's a good question. I think that I guess that would be the question I have for you guys is, that's a good question. Do you think the way that you have the experiment framed right now will allow you to make any sort of conclusions about that once we run it?
If we were going to ask that question, I think it would be more useful to not vary the time and have different concentrations of silver along sort of like a 5-2-1 to sort of see those effects specifically with potassium. But that still depends on what we're trying to answer.
Yeah, I think, that's obviously one of the issues with trying to kind of cover multiple, hypotheses here, is that, the trying to, the sanding's kind of like the side experiment, which I think we can handle, no problem. But yeah, having to kind of fight between compositions and times, it's going to be a question that we have. We're up to what, 1, 2, 3, 4, 5, 6, 7, 8, and then the controls. So what I would say with that is, right now, I think this, this is definitely doable. This is like the typical numbers that we run. We can run this, and as you start to kind of put the data together, if we have the time, we could always try to go back and add something that might help kind of answer those additional questions. Because yeah, I think that's always the concern with trying to kind of answer 3 questions about time, composition, and the sanding effect. So we could always kind of add that. I can't make any promises because this is obviously the first time that we've done this experiment the way that we're doing it now. So, but yeah, and I'm also gonna kind of open it up to having you guys in the lab. So that's one of those things where we could have you in there as well. So yeah, I would say if that's kind of agreeable, we could kind of put those as, if we have some time, we could add those. Any other thoughts on kind of like the, if we're kind of spreading ourselves out too thin with the compositions and times?
So if we're doing 2 and 8 hours, that's a pretty big difference. I'm not sure how much we could infer from that, just having two sets of time that are so far from each other. It just seems like an extremely large gap to me.
I think the idea was that we were gonna have like a lot of them tested for like 2 hours and then just put them in, one of them in there for like a really long time, and see if like just having it sit there like had it like increase exponentially, or if it was just sort of like didn't really make much of a difference.
We could change the time to like 2 and 4 or 4 and 8 to like kind of cut down on that discrepancy of a really, really large time gap. If anybody else wants to add input on that.
Old reports seem like there was a lot of difference between the 4-hour ones in particular.
Yeah, I think Sydney has a point. I kind of expect the time to have like a difference where like just adding like there'd be a lot difference between like the 2 and the 4 hours rather than the 4 and the 8 hours, because like they've already been sitting in there for so long, like there's only so much that they can change. So I feel like maybe making it more like 4 hours would be like less of a time gap, but it would also like show more of a difference. Like I feel like there would not be as much between the 4 and the 8 hours.
I have a quick idea here. So I assume that the numbers are kind of coming from one of the old reports. Could some, if that's true, could you give me the year, and I'll kind of look at it, and we can maybe look at the results and talk about it for a brief second.
Year 16 has 8 hours in it.
Okay, yeah, that one has 1, 2, 4, and 8 hours. Okay, I'm gonna share my screen, and we'll kind of take a look at the results here.
2018 one is a bunch as well.
Okay, so this is the 16, just because that's the one I had up. Let's check the, so this is at the lower end of 350, and they did the 1, 2, 4, and 8. And then if we go to the results, the main thing I'd probably draw your attention to is this. So this is kind of we'll talk about the Weibull analysis later, but this is basically strength from our analysis. And so our control is this line. And then this is kind of what I was talking about with the sodium. You do see an effect with sodium, but it's either to maintain the same strength or even reduce it a little bit. But the potassium, this is probably the closest to your guys' experiment. So this is 350 for 1, 2, 4, and 8 hours. So you do kind of see it peaking at the 4-hour mark. You said 18 also had it. I can take a look at that.
The 2018 had the silver.
Okay. All right, so this is the 2018, and if we kind of go up to the procedure, it is the 400, and it has the varying amounts of silver. So this is the 0125 one I told you about, and it's in sodium. So let's go see what that looks like. Again, mainly let's look at the strength and just kind of see what that looks like. So they actually did 2 bath times, what they call bath times. And so that is the strength. These numbers look a little off, but let's just say that relatively speaking, I think they're correct. So in this case, you did seem to get an increase in the first 2, but then afterwards, these 2 with the 2 and 5% silver actually went down a little bit with the strength, if I'm reading that correctly. But you did see an increase with the concentration, and that's, yeah. And so when I talk about the composition, I just want to show you this real quick. So this is the EDS line scan. So we're basically looking at the cross section of the surface of the glass. So this is the surface here. This is the interior of the glass. And so with silver, we're actually able to pick up a peak right at the surface. Whereas if we look at potassium, which is the green one down here, it's a lot more subtle if we vary potassium. So that's kind of the reason that that potassium on its own is difficult to see. So yeah, so I just kind of wanted to go back and look at a couple of those just so you might have an idea on the times and so forth. Let me take a look at the other 2. So the other 2 look like they're the 350 temperature. So okay, so let's see where we're at right now. So the time is kind of what we were debating there. So yeah, so this is the 400 degrees. We're going to do the same pre-treatment for everything. And yeah, so if you want, does it look like it's between 2 and 4 hours and 2 and 8 hours? Is that what people are thinking of? Do I have that wrong?
I think if we do time, I think we're spreading ourselves out a bit too much. I think with time, we would have to get more data points to see a more sort of clear curve, because you saw if we did 2 and 8, it would have just been a straight line up. We wouldn't have saw that peak at 4. So I think we should just set a standard time and then vary composition of the silver in some fashion.
So I don't, I hate doing this. I don't mean to throw a wrench in this, but let's kind of go down this rabbit hole for a second. So if we wanted to kind of scrap, that idea, because I think you have a point. If you do two temperatures, you'll have to be a little careful about those, conclusions you make, because you'll basically be able to say, I have this data point where I've done nothing. I have this 2 and 8 or 2 and 4, whatever the combination is. You'll have those 3 data points. Is there a way, like if you do want to just do a standard time, let's say 2 hours, just for the sake of argument here. Is there a way to, essentially scrap those 8-hour ones? And could you pool all of that kind of extra resources you had at maybe looking at one condition and then doing more time points? Is that maybe something that you could do? How does that sound? So maybe just taking like the pure potassium or the potassium with silver and then running that for, the 3 or 4 times, and then everything else is looking at composition. Is that still spreading yourself too thin?
You're saying drop sodium, drop that comparison?
I would say, well, for this, I was just saying keep the compositions, basically just remove all of the 8 hours and then focus the time argument on one particular composition. Because I think the spreading yourself thin is because we have different composition.
2 different times.
So maybe, for example, like if we decided to just do it with potassium, then you could maybe do potassium for 1, 4, 8. I don't know what the combination would be, but like then maybe you'd be able to do more time points on that one condition. It's just a thought. I don't mean to throw a wrench into the thing right here, but since it got brought up, I kind of wanted to see what you guys thought.
Instead of doing the sanded and unsanded one, we could just add a time slot to each one of the silver.
Yeah, so the second one here that you've written out, this is kind of more of what I was thinking. If because you'd still be getting multiple points for the composition variable, which is I think what you wanted to look at. Silver, potassium, but then also you would have you would still have the sanded, but then maybe also a so you'd have kind of a sanded versus unsanded comparison, but then also to look at time. Now, in this case, you have 4 points instead of the 2. That's definitely what I was kind of throwing out there as an option. What do you guys think about that?
If we did the different concentrations of like, if we did like the potassium at like 4 different time slots, and then the like 95% sodium, 5% silver at 4 different time slots, would we also be able to do a sanded one, like with just like as like a standalone?
Let me make sure I have that correct. So so you're saying kind of stick with the potassium, or sorry, sodium and silver for the different times, and then also do potassium at those same different times?
Well, like just taking like try to like reduce down the concentrations. One of them would just be like 100% potassium, and the other one would be 5% silver, but then using the sodium with it, just since like it's like not getting as much confused with like mixing the potassium and the silver together. Then those would just be like our 2 concentrations. If we did like 4 different times, so it'd be like 8 of those total. Would we still be able to include sanding in there? Would that be too much?
I think we could do effectively that would be a 9th, right? If I did my counting correctly.
Yeah.
Yeah. No, I think we could do 9. Yeah. So I guess this is kind of maybe a good point to kind of ask the question or propose it is, we had something, and I don't I definitely don't want to discourage you from using that, but I just kind of wanted to throw out some other options if you were concerned about the time effect. So where do you guys think? Do you think we should kind of stick with what we had, or what do you think about the kind of some of the new proposals?
Personally, I feel like we could draw more definite conclusions from the second setup. Like, I feel like it's easier to determine, the effects of the different changes. In the first one, it was just like, I feel like the variables were too mixed up, and it would be hard to really get definite data and determine what was influencing what.
I agree. I think that second set we'll find more because of because we have enough different data points from different time slots. So I think the more different times that we test, the better results and more clear results and effects that we're going to find.
Okay, so I just want to make sure I've got it here. So it looks like 4 of them would be the 5% silver in sodium, Na, and so you'd have 4 time slots there. Right now it's just 1, 2, 3, 4, and then you would have another set with those same times. And from what I'm seeing here in the what's being written right now, do you want to do the potassium 95, silver 5? Is that the idea?
I'm not sure. I personally would want to do potassium, but I feel like that's still spreading us out a lot. It's less spread out than the top one, but it's still, I feel like we still need to narrow it down to either time or composition. I'm personally really interested if the potassium would block the silver, vice versa, at different concentrations, but that's just my thought.
So are you thinking the 95% potassium, 5% silver?
Yes.
But then you're also okay. But then you're also kind of talking about doing silver on its own. I think is that the idea? I want to make sure I have the overall thought down.
I'm not really set. I just think setting a set time and then changing composition of the silver from like 5 to 0, just to see how much they impede each other, would be more interesting to me currently. I don't
I
really
kind of agree with Alex too. Like, I feel like if we're varying the time for the sodium, we could do some separate trials with the potassium and the silver and just have a set time on that and vary the concentrations.
Just so that I kind of have an idea of your guys' thought, would you mind kind of typing it up as an alternative here? And then we can kind of just make sure that we've got everything. That way everybody can just kind of be on the same page and see what we're talking about.
So for like, if we were to do a set time, we'd probably need to do maybe like 2 or 4 hours, because that kind of seems like it was in the middle. I'm not really sure how much time everyone wanted to do for the set concentration, or I mean for the varying the concentration one.
I'm thinking 2 or less. 2 or 1 would probably be best.
Yeah. Option 3, I'm kind of confused on what's going on. So if whoever wanted to explain what that one was.
So for option 3, it looks like would we make 3 different hypotheses? It's kind of separated into 3 groups. So like testing concentration on the top, testing time in the middle, and then testing the sanded on the bottom.
Yeah, so I think as written, it might be a little, I'm not sure if that's exactly what you're talking about, Alex.
I was thinking having sodium just thinking that it won't impede the silver's movement, and then also having a set with potassium at different concentrations and seeing how it impedes.
Okay. So that was kind of the idea, was looking at the different times with a standard sort of silver, and then looking at composition at a standard time. So the 2 hour, then you would have the most data for. So this is so yeah. So I think I guess now what we need to kind of think about is the kind of original thing that we came up with. We've got the second one where I think the focus was looking mostly at time and kind of picking 2 different compositions, and obviously the silver is thrown in there. And then this last one where we're looking at kind of a mix of composition and then time. So just to kind of we can fine tune these, but maybe we should just kind of focus on those options. And so I think maybe the chat's the best way to do this. Again, just kind of I want to make sure that you have the main experiment down before we head out today. So if you want to, in the chat, maybe just kind of choose what option it best matches what you want to do, and then I think maybe we would just go with that and then tweak that. So option 1, option 2, or option 3. So if you want to just put those in the chat, and then we'll kind of do a roll call and see what we have.
Wait, sorry, we might have said this already. In option 1, we're not varying the time, correct?
No, it's just concentration in the
Okay.
solvent,
Okay.
salt.
Yeah, so like option 1 is like varying only concentration, option 2 is varying only the time, and then option 3 is kind of like we're just doing everything. I'd like we're doing like both of them.
Okay, cool. Thanks.
So from what I can see, it looks like we've got a majority for 1, because we do have 16 in the class. So option 1 is basically looking at, you said composition alone. I want to make sure I have that right.
Composition as well as the solvent salt.
Okay. Okay. So we've got a sodium, 100% sodium, and then we add in 125% of silver to sodium. We've got 100% potassium, and then we add in 3 different compositions of silver to that. And then we've got the sanded kind of side experiment there. And so that's 9, it looks like. That's so it is, that's, and then, so for that, we're picking a standard time on that and standard temperature, as I believe on that one. Is that
Yeah, I believe it's 2 hours for all of them.
okay?
2 hours and 400 degrees Celsius.
Okay, so it looks like we've got the experiment then. I do have one more question, just because we haven't done the sanded one. What are you kind of thinking for? So when we sand it, we obviously have options. What kind of sanding would you like us to do? You know, if you kind of think of the grits that we have in the lab, do you want a really rough surface, or do you want us to go with like the finest sand?
I feel like rough, like the roughest would be probably like the goal is to make it really rough.
So something like a 300 grit, or something in that range, or
yeah.
600 I got in the chat. I think both of those would be, you know, pretty rough when you have a fairly sanded surface. We can also, you know, if you want some slight differences to that, you could kind of look up the, you know, the size of those particles if you want, and let me know. But for now, I would choose something between 3 and 6, unless you have some other thoughts. Okay, so everybody good with this kind of 400 degrees, 2 hours? Is it okay if the pre-treatment, the preheat, is at the same temperature? Just kind of, you know, having everything at 400, throwing it in the furnace without the salt. Is that okay to keep the same temperature?
Yeah, I think it says 350, doesn't it? I think that was just sort of arbitrary. I don't know.
Before we had, yeah.
I think that was David, but he's not here, so I don't know.
Okay. Okay, so yeah, so let's go with that, and then you know, half an hour is fine, whatever really works for you guys, and then we'll just kind of air cool. That sounds good. And then any other? I don't want to hold you up too long. So any other things we want to bring up? Any other questions about the option that we're going with? All right, so I don't want to hold you too long. So for typically on Friday, we'd have a lecture. And so I'm going to post something for kind of in lieu of that Friday lecture, because I do want to kind of go over a little bit of the assignment, because we didn't have much time to talk about that. So keep a lookout. I'll post an email when it's up, but I do want to kind of go over the assignment a little bit and the job safety aspect of that. So I'll post something this week, and then if you have any questions about the assignment, please let me know. But yeah, let's kind of go. Let's say that we've got option 1 as our experiment, and you know, if you have any alterations, you know, let me know as soon as possible. But for now, I'll say that this is what we've got. So all right, if there are no other questions, then good work, guys. Sorry it took so long, but that's how it kind of goes with a lot of people here. So so yeah, have a good rest of your week, and let me know if you have any questions or concerns about the experiment.
Thank you.